So example 1, there's a body of mass 5 kilograms is pulled along a smooth horizontal table by a horizontal force of magnitude 10 newtons. And we need to find the normal reaction and the acceleration. So we'll draw the standard picture first. So we have a horizontal ground, the mass on it of 5 kilograms, and a force of 10 newtons acts on it, and that's going to produce an acceleration which we don't know yet, so we're going to call it A, and we have to add the weight in, so that'll be 5g, and there's a normal reaction R. And part A, we need to find the magnitude of the normal reaction. We just have to work out what R is. So part A, here, because the object is only moving to the right and there's no up or down motion, we have that R must equal 5g, so up must equal down. So here we can say that we're going to resolve vertically. So up equals down, so R equals 5g, and that's the answer. And if we want, we can work it out. So 5g equals 5 times 9.8 equals 49 newtons. So that's the normal reaction going up, and then we need to work out the acceleration, and here we're going to use F equals ma. So for part B, we know that F equals ma. We're given, therefore we're given that F is 10 equals the mass of 5 kilograms times the acceleration, and then we can solve for A. So therefore acceleration is 2 meters per second squared. Okay, example number 2. This time we've got a body of mass 10 kilograms. It's acted on by a force F and it causes it to accelerate 3 meters per second. So we have to find the normal reaction and find the force F. So we'll begin with the picture. So that's 10 kilograms. So this time the force is the unknown, so F is unknown, but we know what the acceleration is. That's 3 meters per second squared, and we have a weight of 10g and a normal reaction R. So part A is the same as the previous example. Up equals down, so R equals 10g. So therefore R equals 10 times 9.8 is 98 newtons. You can also leave the answer as 10g also, that's also acceptable. Okay, part B, we need to work out F, so we'll begin with F equals ma and fill in. So F is the unknown, equals a mass of 10 kilograms times the acceleration of 3, so equals 30 newtons. And example number 3, so we have this time an unknown mass, but we know the acceleration and the force. So we have a mass of m kilograms and it's acted on by a force of 50 newtons and it accelerates by 2 meters per second squared. So again we'll draw the picture. So the standard picture, horizontal ground, the object on it of mass m kilograms, a force of 50 newtons. Notice that I also put the units in the picture. This helps to distinguish what's going on. And we have an acceleration, double arrow, 2 meters per second squared. So acceleration is double arrow and a force is a single arrow. Okay, so we can put in the weight. The weight this time is mg newtons and a normal reaction of r newtons. Okay, notice also in this question it's the other way around. We need to get the mass first and then get the normal reaction. We can't get r until we've worked out m. That's why part A is to work out the mass first. So part A, we begin with F equals ma and fill in. So the force is 50 newtons equals m times acceleration is 2. Therefore we can work out the mass, divide by 2, so the mass is 25 kilograms. And part B, now that we know the mass, we can work out the normal reaction. So up equals down. So the normal reaction R equals 25G equals 25 times 9.8. 25 times 9.8 equals 245 newtons. Okay, so far these have all been basic examples where the force has been horizontal. In the next lecture we'll do it a little bit harder, where instead of a horizontal force we're going to have a force at an angle. So we'll have to work out, say, an angle of 30 degrees, how to deal with these cases, and that'll be the next video.